All right, so we have just found a determinant of a 2 by 2 matrix. It was pretty simple to do, just cross multiplying and subtracting. Now we're going to do 3 by 3 matrix, okay? And there's two methods that we're going to talk about here. So the first method is called the diagonals method. It's a little bit crazier than before. So the first thing that you have to do whenever you take the determinant of a 3 by 3 is take the first two columns and duplicate them right after the last column. Okay, so this is what it looks like. So assuming that this is the original matrix, you're going to take the first two columns, that's A, D, G, B, E, H, and then you're going to write it right at the end. So take a look at the next part of this. So I just wrote those two columns right at the end. Now it proceeds similarly to the 2 by 2 matrix. You're still going to find the products of the elements in the major diagonals, okay? But you're going to add up each one of those products. So A times E times I, that's one of the products, plus B times F times G, that's the other product, plus C times D times H, that's the other product, okay? Minus, now do the same thing along the minor diagonals, okay? And adding up each one of those. So the ones in the blue, that'll just be some sort of number after you get it, and simplify it. The reds will also be a number, just subtract those two numbers. There's your diagonal method. There's your determinant of a 3 by 3 matrix. So you might want to write something down, how to find the determinant of 3 by 3 with the diagonal method, and then let's try it. Okay. Oh, that's exactly what I just said it was. Okay. So let's find this on exercise 5 here, the determinant of this 3 by 3 matrix. So what we said is, first take the first two columns, write them at the end. So 4, -3, 0, and then going down, -1, -2, and 5. Okay? So let me just kind of make this really colorful here. Start with the green. So this first product, and I need to put this in parentheses so that I know that I have this whole entire quantity that I got to add up. So 4 times -2 times 1 is -8, plus -1 times -1 times 0 is 0, and 2 times -3 times 5, so 2 times -3 is -6, -6 times 5, got plus a -30, right? Okay. Now let's switch colors again. How about red? Sounds good. Okay. So minus this whole quantity in parentheses, 0 times -2 times 2. I always like those because that's just 0. Plus 5 times -1 times 4. That's -20. Plus 1 times -3 times -1. Negatives cancel, so that's just a 3. Okay. Let me just switch back to blue just because. Whatever. Okay. So in this green one, whenever I add it up, I get a -38 minus, whenever I add up the one that's in the red parentheses, I get -17. Chop, chop. Okay. And then -38 plus 17, which is a -21. There we go. So there is the determinant of that 3 by 3 matrix. It's not too involved, but there are some places where you can definitely make some arithmetic errors whenever you're finding the determinant here, because there's so many things to add up and subtract, multiply. Okay. All right. So why don't you try this on your own with this exercise? Find the determinant of A. So pause the video, find it, and then come back. Let's see if you did it right. Alright, let's check it. So, whenever you do it with the diagonal method, remember you take the first two columns, write them down again after the last column. Then I'm going to take all the purples, multiply them together and add them, minus all the greens, multiply them together and add them. I get a -77 for the determinant of that matrix. Okay, so that's the diagonals method. We've got one more. It's called expansion by minors. Okay, and an expansion by minors uses 2 by 2 matrices, the determinant of 2 by 2 matrices, to find the determinant of a 3 by 3. And as a matter of fact, this is how you would do it for anything bigger than 3 by 3. 4 by 4 would use this method, 5 by 5, and so on, if you were crazy enough to try one of those by hand. Okay, so this is what you do. So just watch the animation here. Okay, so what I do is I take that first element and I'm going to bring it outside. It's going to be like a scalar. Okay, you cross out the row that it's in and the column that it's in, and that leaves you a 2 by 2. You're going to find the determinant of that leftover 2 by 2. Okay, remember how you do that is you just take the majors minus the minor products. Okay, so the first one was plus, the next one's going to be minus, and I'm going to pull out the b. So I'm going to pull out the b. Now I'm going to cross out the row and the column that b is in, and I'm left with a 2 by 2. So the 2 by 2 that I would find the determinant of is going down d, g, f, I, as you can see right down there. Okay, I did a plus, I did a minus, the next one's going to be a plus, and I'm going to pull out the c. Okay, so plus c, cross out the row, cross out the column that c is a part of, it leaves you with a 2 by 2, d, g, e, f. Then find that 2 by 2 determinant. Okay, so like I said, if you're going to do anything bigger than 3 by 3, you would use this method. Say a 4 by 4 would turn into 3 by 3s, and then you take the 3 by 3s and turn them into 2 by 2s. Whew, it'd be a heck of a process. Anyway, so let's see if we can use expansion by minors to find the determinant of this 3 by 3 matrix. Okay, so remember, it goes plus, minus, plus whenever I pull out each of those numbers. So the first one is, it's going to be plus, but my number is negative, so it's going to be negative 1 times the determinant of, and I cross out this row, I cross out this column, and I'm left with 2, 3, 4, and 2. Okay, so now let's switch colors. How about a red one? Get the eraser up here, erase all this business. The next one is a minus, and I'm going to pull out this 1, cross out that row, cross out this column, and I'm going to find the determinant of the matrix 0, 3, 3, 2. Let's change colors one more time. Purple. Okay. Eraser. This time it's a plus. A plus. I'm going to pull out this 2. Cross out the row, cross out the column, and I'm left with a 2 by 2. 0, 3, 2, 4. Okay, so now I'm going to find each of these 2 by 2 determinants. Okay, so this should be equal to a negative 1 times, this one is a 4, I guess I could put the 1 out there, minus 12, minus 1 again, 0, minus 9, and then plus 2 times 0 minus 6. Okay, and now let's just simplify here. So inside this first set of parentheses I have negative 8. Negative 1 times negative 8 gives me positive 8. Here I have negative 9. Negative times that negative makes that plus 9. And this is a negative 6. 2 times that is negative 12. Here I have 17 minus 12, which is 5. There is the determinant of that 3 by 3 matrix using expansion by minors. Okay, which method do you prefer? Whatever. You choose, you pick. Okay, so why don't you try it here on exercise 6b. You find the determinant of that 3 by 3 matrix using expansion by minors. Alright, let's see if you get it right. So using expansion by minors, I'm putting myself a little reminder up here. It's plus, minus, plus. Okay, I'm going to first pull out the 5 and then cross out the row and the column that it's part of and find the 2 by 2 matrix, the 2 by 2 determinant, negative 2, 3, 1, 3, right there. And then I have a minus. I pull out the 6 and cross out the row and the column that it's part of, and I have 1, 0, 1, 3. Okay, and then finally I have a plus, pull out the 7, and the determinant is the 2 by 2 formed by crossing out the row and the column, 1, 0, negative 2, 3. So you do the math on that, you get a negative 42. the exact opposite of the answer to the ultimate question of life, the universe, and everything. Okay, so that concludes how to find the determinant of a 2 by 2 or a 3 by 3 matrix.